Okay, Assalamualaikum and hi everyone. My name is Muhammad Syaitimi bin Muhammad Radwan. My metric number is CE220041 and I am from Group 5. Today I will explain about the introduction from our group project, which is Cyborg Beast. So, first of all, limb loss can significantly affect a person's ability to perform everyday tasks such as grasping object or writing. So if we lost our hand or our hand, shoulder, including shoulder, arms, wrist, cannot perform or cannot work. So it will give us difficulties to perform our daily tasks such as eating or any activities involve the hand using. So unlike high costing prosthetic hands that are often inaccessible, our cyborg beasts offer an affordable 3D printed solution. This prosthetic design integrates an ESP32 microcontroller as a as a board as a brain to control the data from the user to the um, from the analog to the digital data, and a servo motor to electronically actuate finger movement. With a simple push-button control, user can easily initiate a gripping motion, making it both intuitive and user-friendly. So our goal in this project is to provide a practical and functional prosthetic option while promoting continued innovation in accessible assistive technologies. That's all from me. Thank you.
Next, for the methodology, this project follow a structured workflow involving mechanical design, electronic integration, and embedded programming. For hardware components, there are ESP32 for the microcontroller to handle logic and control, next, which is the servo motor to control the finger movement, third, which is the push button, input to trigger motion, next, which is the PLF filament material used for the 3D printer to print the prosthetic components. Next, for the software tools, for this project we use uh, both electronic control and mechanical design for the uh, prosthetic hands. So we use Trinket to utilize to create and customize the 3D model of the hand, allowing for precise component fitting and structural design. Second software that we use for this project, which is Arduino IDE, was used to code and run the code and to develop and output the control code to ESP32. So to enabling seamless interaction between push button input and servo motor actuation. Next, I will explain about project for this project. So to control process where the system start by initializing the servo motor and push button through the ESP32 microcontroller. It then enter a continuous loop that monitor a button state. When the push button is pressed, the ESP32 send a signal to the servo motor to rotate, causing the prosthetic finger to close. When the button is released, the servo will return to its original position, allowing the finger to open. This loop provides a responsive and effective way to control the finger's movement based on real-time user input. So that's all.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Imanaki Nisha bin Eli Basira, CE220105. So we continue to the result and analysis. Right here we have a image which is for our hand robot. So basically we can see that in the top of the hand is ESP32, which act as a microcontroller connected with the servo motor that function to move the finger. So next we will go through one by one. First is prototype performance. Our final prototype of the 3D printed prosthetic hand worked well and showed that it could perform a basic gripping motion using just one servo motor controlled by the ESP32 microcontroller. After putting all the parts together, we tested the hand and it responded quickly and smoothly when the button was pressed. Next, for second, which is user-friendly operation, the system was user-friendly and responsive because the push button provided a simple and intuitive control method, making it easy for user to operate the prosthetic hand without the need for complex sensor or interfaces. Each time the button was pressed, the finger flexed inward to grip, and when released, it returned immediately to its original position without any delay or jitter, confirming the reliability of the control system. And next, for the third one is the functional capability. For the functional, the prosthetic hand was able to grasp small and lightweight objects such as rubber ball, plastic utensils, and paper cups. Even though only two finger was actuated, the static thumb was strategically positioned at an opposable angle to assist in forming a stable grip. This allowed the device to perform useful grasping action like pinching or holding a spoon, which are essential for daily activities. For the fourth one is low cost and efficient design. In terms of the cost, the entire project was built for under RM100. We achieved this low cost by using open source tools like Tinkercad for designing the 3D parts and Arduino IDE for programming. Battery filament was used for all printed parts and the component assembled cleanly without distortion. The servo motor fit well into its mount and wire routing was efficiently handled in the design. And for the last one is the limitation and challenge. There were some challenge, which is first is adjusting the tension of the tendon was tricky because if too tight or too loose affected how well the finger moved. Also, the hand only had two moving fingers, so it couldn't perform more complex grips. There were no sensors to give feedback on grip strength either. For the future improvement, looking ahead, future improvement could include adding more servo motor to control multiple figures independently, enabling more complex grip types like cylindrical or spherical grabs. Additionally, integrated sensors such as flex or pressure sensor or even EMG sensor for muscle control could greatly enhance functionality. The ESP32 built-in Bluetooth also allows for possible wireless control via a mobile app. Overall, despite being a simple and low-cost system, our prosthetic hand serves as a strong proof of concept for assistive technology. It demonstrates how 3D printing and embedded electronics can come together to create accessible and functional device, especially in educational or humanitarian settings.
Good day to everyone. My name is Talbing Raj. My matrix ID is DE220110. And I'm here to explain about the conclusion part. So this project presents a low-cost 3D printed prosthetic hand prototype powered by an ESP32 microcontroller and a single SJ90 servo motor, which is capable of performing basic gripping actions using a tactile push button. Developed using Tinkercad and open source tool,
The design emphasized the potential of combining affordable electronics with simple mechanical components to create functional assistive devices. While while the current versions support only single finger actuation and lacks feedback mechanisms, it provides a solid foundation for the future improvements such as multi-finger control, EMG input, and wireless connectivity through Bluetooth. That's all from us from the group one. Thank you.